Finally, the very rare trajectory. This is 3i Atlas. This is Mars. 3i Atlas is about to swing by, and a fleet of camera-ready rovers and orbiters are standing by to snap some pictures.
3 days ago, James Webb detected something that changed everything about 3i Atlas. The comet everyone assumed would safely pass. Mars has fired controlled pulses 23 times in the past week. Each pulse nudges it closer to a direct collision trajectory. NASA's updated calculations show a 73% probability of Mars impact in 127 days. But what terrifies scientists isn't the collision itself. It's that the pulses follow a precise pattern that suggests this comet might not be natural at all.
3i Atlas, whether it's a rock, a natural object, or perhaps it might be alien technology.
The visitor that shouldn't exist. Something out there moved in a way nothing in space should. It wasn't just fast, it was focused, as if it had a destination. That was the first sign that what entered our solar system on the 1st of July, 2025, was no ordinary cosmic wanderer. Comets pulled toward the sun usually slow as they shed ice and gas. This one, later named 3i Atlas, broke the rule. Its acceleration was too precise to dismiss as an error, and no natural force, gravity, solar wind, or outgassing could explain it. The discovery shook observatories worldwide. Then it changed again. Its coma, the glowing halo of gas and dust, brightened far too quickly, followed by ultraviolet emissions spiking and carbon dioxide outflows surging as if something inside had stirred awake after eons in the dark. What had looked like a frozen lump of ice and rock began behaving like it had just switched on. The more telescopes turned toward it, the stranger it became. Instead of settling into predictable comet behavior, its path curved inward in a tightening arc, as if it were steering. Weeks later, ground stations detected faint rhythmic pulses hidden in its tail. So regular they looked less like random turbulence and more like a signal. In control rooms, the mood shifted from fascination to unease. The data painted a picture no one wanted to believe. An interstellar body behaving as though it had intent. Its acceleration, its sudden flare, and now the measured, repeating pulse suggested not just an object, but perhaps a messenger, or something worse.
With 0 meaning it's a natural object, like a comet, for sure, and 10 meaning it's definitely a technological object.
And as analysts traced its arc forward, dread deepened. The pulses lined up with its new course, pointing straight toward Mars. Yet as scientists charted that deadly line through the void, they noticed something stranger still. Those pulses weren't just steady. They were too precise, as if every beat were a step in a countdown no comet should ever keep. The unexplainable 17-minute signal. The 17-minute pulses weren't random. They were surgical. James Webb's analysis confirmed what NASA hoped wasn't true. Each pulse delivered exactly the right amount of thrust to keep Mars locked in the crosshairs. Computer simulations showed the terrifying math. Even a 10-kilometer-per-second velocity change could shift a near miss into direct impact. That was the moment the chatter in mission control went silent. Comets don't keep time. The pulses weren't random jets of gas boiling off the surface, the kind that usually erupt chaotically as comets warm near the sun. These were clean, evenly spaced bursts, steady thrusts that behaved more like a propulsion system than a natural vent. Further analysis lined up perfectly. The bursts were deliberate, pushing the object with measurable force. That was when the excitement in the room gave way to unease. Ordinary comets stumble along on paths carved by gravity. their plumes kicking out in uneven sprays that changed little about their overall course. But 3I Atlas was doing something different. Each pulse gave it a tiny nudge in just the right direction, as if it were fine-tuning its approach. The math was clear. This was no random drift. Simulations at JPL added to the tension. Feeding in the pulse data, researchers found that even a modest velocity increase, just 10 kilometers per second, could shift its path enough to turn a distant flyby into a collision course with Mars. Worse still, the direction of each thrust lined up with the red planet's orbital plane, suggesting that whatever was driving the pulses wasn't wandering blindly through space. It appeared to be steering. The projected window for a potential impact narrowed quickly. By late analysis, the critical period may be sooner than expected.
We have to better understand how active this object is, and then we can find the size estimate and get a good idea.
That meant every new burst could tip the balance between a harmless pass and a catastrophic strike. Control rooms worldwide stopped treating the event as a distant curiosity. They were now watching a countdown. The shift in atmosphere was unmistakable. What had started as an exciting anomaly became a looming threat. Astronomers and engineers stared at their monitors, waiting for the next pulse, knowing that each one might be pushing 3I Atlas closer to Mars. But while all eyes stayed locked on the approaching threat, few realized the most unsettling response wasn't coming from the comet at all. It was coming from the planet, waiting in its path. The planet that answered back. For weeks, scientists treated 3I Atlas as an approaching threat, something out there coming in. Then Mars began to act as if it had heard the comet's approach. ESA's ExoMars Trace Gas Orbiter recorded a sudden surge of xenon isotopes rising through the thin Martian air. Spectral scans traced the source to fissures in the Cerberus fossae region, a long, quiet scar across the planet's surface. Almost at the same time, seismometers picked up a low, repeating tremor beneath the crust, along with a 3 Kelvin rise in subsurface temperature. The most unsettling clue came last: faint electromagnetic pulses, timed with eerie precision at 17-minute intervals, the same rhythm already measured in the comet's light curve. For planetary scientists, that rhythm was the first true shock. Impacts and tidal stresses can shake a world, but they do not arrive as clock-steady beats. The data suggested that Mars was not being randomly disturbed. It was responding, as if the approaching object had already reached across space and touched the planet's buried systems. In briefings, a grim idea took hold. Perhaps the collision we fear is not the beginning of the event. It is the final step in a process already underway. That suspicion turned into dread when astronomers noticed something no natural object should achieve. Every pulse from the visitor adjusted its path, as if zeroing in on Mars with sniper-like accuracy. The question was no longer whether it would hit, but who or what was guiding it. Harvard's shocking theory. Harvard's A.V. Loeb just published the paper NASA didn't want to see. 3I Atlas isn't a comet. It's an artificial probe. The evidence is undeniable. When he released his team's analysis, the usual chatter in observatories turned into a stunned, uneasy silence. The report didn't see it as frozen gases or fractured ice. It asked the question no one wanted to hear. What if 3I Atlas wasn't a comet at all, but a manufactured probe?
3I Atlas, whether it's a rock, a natural object, or perhaps it might be alien technology.
Adjusting its path with unsettling precision toward Mars? The claim wasn't built on speculation. Loeb's group backed it with data that had been building for weeks. Radar signals from the Mars Reconnaissance Orbiter and Earth-based Goldstone antennas came back sharper and cleaner than anything expected from an icy, porous comet. Natural comets return fuzzy, weak radar signals from their icy surfaces. 3I Atlas returns sharp, strong echoes, like radar bouncing off manufactured metal. The reports unsettled even seasoned NASA engineers. Some began speaking off-record, describing the radar returns as unlike anything in the textbooks. As those details leaked, discussions inside agencies grew tense, no longer about simple observation, but about the possibility of deliberate design. Amateur astronomers soon added fuel to the fire. Using long-exposure imaging, several observers independently captured faint green needle-like streams, projecting from the object's core, 3 in total, aligned toward Mars. More disturbing was that these streams pulsed in sync with the 17-minute bursts detected earlier, as if the entire structure was operating to a precise rhythm. For Loeb's team, the alignment was the most unsettling detail. It suggested the object wasn't merely passing through space, but was guiding itself, adjusting course to keep Mars in its sights. Their paper went further, outlining scenarios that ranged from a controlled impact to the deployment of smaller payloads, devices, sensors, or even biological material, once the object reached its target. By the time these findings circulated, the projected close approach of 3I Atlas had tightened to just 1.95 million kilometers from Mars, alarmingly close on a planetary scale. What had started as an astronomical curiosity now looked like a calculated approach. The shift in mood across observatories and space agencies was unmistakable. Analysts were no longer debating comet chemistry. They were running simulations of what might happen if an engineered object made contact with the red planet. And just as this harsh picture took shape, the debate split the scientific community in two. Between those demanding caution, in case this was humanity's first brush with alien technology, and those warning that even asking the question risked public panic. But the real question is, what could such a strike actually do to Mars? If that question chills you as much as it did the scientists staring at the data, hit the like button to keep this investigation in the spotlight, as we uncover what such a strike could mean for Mars. The Doomsday Math: Mars on the Edge of Annihilation. The more the models updated, the more the countdown felt real. If 3I Atlas strikes Mars, it will not just scar a distant world, it will wipe out 2 decades of human effort. The math is blunt. 10 billion tons of icy metal, hitting at 57 kilometers per second, equals complete annihilation of everything we've built there. Perseverance, Curiosity, every rover and orbiter vaporized in an instant. 20 years of exploration and priceless data, erased in seconds. The physical destruction, as catastrophic as it is, may be the smallest problem. The real fear lies in what that impact could unleash. A collision so violent could rip open deep layers of Mars that have been sealed for eons, scattering material we have never studied, and perhaps never should. If microbial life hides beneath the crust, or dormant chemical systems linger in the rock, the strike could wake them in ways no one can predict. The force would blast debris high above the planet's thin atmosphere. Some of that material would fall back like a deadly hailstorm. The rest could be ejected into space, entering new orbits that might eventually cross Earth's path, turning fragments of the impact into future threats to our satellites and even our planet's surface. But the immediate devastation would be on Mars itself. Every rover, lander, and orbiter we have sent, Perseverance, Curiosity, MAVEN, Trace Gas Orbiter, and others, would be destroyed either by the blast or by the chaos that followed. Communication networks would collapse. Years of carefully collected data on the Martian climate and potential signs of ancient life would be lost in seconds. Then comes the part that keeps scientists awake at night: the unknown reactions. If this is not a mindless comet, but an artificial probe, then the impact may not be meant to destroy. It may be meant to deliver. That possibility changes everything. We might not be watching a natural disaster unfold, but a calculated event. Something aimed at Mars for a reason we do not yet understand. And that leaves the hardest question hanging over every emergency meeting. If 3I Atlas is coming as a messenger, not a weapon, what is it carrying, and what has it come to Mars to do? Mars's hidden life, the collision that could wake it. The danger from 3I Atlas isn't just measured in blast force and crater size. The real threat begins beneath Mars's frozen crust. A strike powerful enough to rattle the planet could rupture ancient ice-locked reservoirs, vent buried brines, and stir whatever has been sealed away for eons. For decades, scientists worried that digging too deep might wake something we weren't ready to face. This impact could do it all at once. Under the frozen crust lie hints of something older, maybe even alive. Subsurface briny lakes detected in radar scans, chemical traces of methane that sometimes spike and vanish.
Our team has discovered methane on Mars. The big question is, what is the origin of this methane?
And sediments that tell of ancient rivers and seas. We have always probed gently, hoping to find evidence of microbial life without disturbing whatever may still linger underground. That caution is about to be tested. If 3I Atlas slams into Mars, the impact won't just gouge a crater. It could shatter the crust and rip open those hidden reservoirs we have barely begun to understand. This is no abstract risk. Scientists have long suspected that beneath Mars's surface, locked in frozen soils and salty water pockets, there could be microbial colonies, organisms that adapted to the cold and the dark long after the planet lost its rivers and thick atmosphere. Some could be dormant, waiting for warmth or liquid water to stir them awake. Others might have evolved in ways we cannot yet imagine. An impact of this magnitude would deliver both the heat and the liquid water that such organisms might need. It could melt subsurface ice into temporary warm pools and flood tunnels, and caverns with scalding slurries. What has lain sealed for ages might suddenly be mixed, exposed, and possibly revived. And then there is the threat from the other direction. Comets are not always sterile. Some carry complex organics or even hardy microbes frozen in their cores. If 3I Atlas brings its own microscopic hitchhikers, the collision could mix them with Martian materials, creating combinations we have never encountered, hybrids shaped by two worlds and unleashed in a new environment. Biologists call this possibility reverse panspermia. Instead of us spreading Earth life to other worlds, something alien arrives to seed Mars. The fear is not just contamination, but transformation, an uncontrolled biological reaction that could reshape the planet before we understand what we are dealing with. This is why the stakes have shifted. We are no longer talking only about craters and dust storms. We are talking about the forced awakening of whatever has been locked beneath the Martian surface and the chance introduction of something from far beyond the solar system. As the comet's trajectory firms up, every new calculation deepens the unease. The question is no longer just whether Mars will survive the strike. It is what Mars might become afterward, and whether what starts there could, in time, reach us. And as the countdown tightens, researchers have begun to notice something even stranger. The comet's path itself seems to be carrying a hidden pattern, as if the approach were a message written across the stars. The hidden code in the trajectory. Something in 3I Atlas's path didn't add up. Its approach toward Mars wasn't random, and the numbers describing that path started to look less like orbital mechanics and more like instructions. That suspicion first came from a small group at the SETI Institute. Instead of treating the comet as just another rogue visitor, they treated its motion like a message, something that might be hiding in plain sight. They started with publicly available data: the comet's trajectory, its approach speed, the timing of its closest pass, and the gravitational pulls shaping its path. Then they stripped it into raw binary code, the same kind of encoding used in deep space signals, and ran it through compression filters designed for interstellar communication. What came out wasn't noise. The decoded strings showed repeating loops of numbers that mapped to the atomic weights of familiar building blocks: carbon, oxygen, silicon, and iron. It looked less like a random product of orbital math and more like a list of ingredients. As they dug deeper, new patterns appeared. Prime numbers emerged in a countdown-like sequence. The spaces between those primes weren't random either. They formed recursive intervals similar to the structure of modern encryption protocols. It wasn't a radio broadcast. The message seemed baked into the comet's own trajectory, the timing of its passes, and the arc of its path, carrying information like a slow-moving signal. That raised an uncomfortable possibility. Maybe the comet's motion wasn't just obeying gravity. Maybe it was following a path designed to be read. And if so, whoever set it in motion might be using Mars as a page in a much larger script. The unease grew when analysts noticed where the projected path would skim closest over Mars. The line cut directly across Elysium Planitia, a relatively smooth plane with geological oddities that have puzzled researchers for decades: concentric ridges, spiral-like formations, and one perfectly circular basin about 3.5 kilometers across. The basin had no clear volcanic or impact origin. In its center was a cluster of crystalline silicates that reflected sunlight in a steady infrared pulse, like a lighthouse beacon that no one admitted to building. For years, it was written off as a geological curiosity. Now, with the comet's descent line crossing directly above it, the coincidence was harder to dismiss. Was it just a natural formation, or a marker, possibly even a target? At Webb's Mission Operations Center, technicians adjusted the telescope's position to get a better angle, chasing the comet's faint glow. Then, during a routine scan, something unexpected flickered in the background of the feed, a faint shape moving in tandem with 3I Atlas. That single glimpse turned an already tense investigation into something darker. If the comet wasn't alone, the coded path might not be the only thing we were meant to notice. If that thought unsettles you as much as it did the analysts, share this with your friends so they can see why the comet's path may not be as simple or as solitary as it first appeared. The Dark Twin, a silent companion in the void. Astronomers thought they were tracking just one object. Then James Webb caught something worse, a second shape, a perfect shadow trailing 3I Atlas at a fixed distance of about 0.07 astronomical units, as if tethered to it yet leaving no heat, no reflected light, nothing for radar to grasp. It moved in lockstep with the comet, silent and invisible except for the way it blotted out stars behind it. This was no fragment of ice or rock tumbling in its wake. The object reflected no sunlight, emitted no heat, and slipped past radar like empty space. Yet, when the photometric data arrived, the readings revealed a precise dip in background light, a clean, measurable silhouette tracking the comet's path. Through each gravitational shift and change in velocity, it kept the same distance, as if held in place by an unseen control. Plotting it in polar coordinates only deepened the unease. The dark body's orbit mirrored 3I Atlas with textbook precision. It did not wobble under the sun's pull or Mars's influence. It simply followed. Scientists began asking whether this was a natural phenomenon at all,
I would actually be quite concerned about it not being natural.
Was it a detached mass bound by an unknown force, a hidden craft, or a decoy riding in its slipstream? As observatories worldwide focused on the dark twin, researchers dug through the comet's travel record. That's when a more disturbing pattern surfaced. The comet's closest passes by the Sun, Earth, and now Mars had lined up with precise astronomical milestones, dates too exact to dismiss as chance. The next approach would occur near the autumnal equinox. Another critical point followed on October 5th, then again on November 11th, moments of rare planetary resonance that repeat in a strict 54-year cycle. The last time this alignment coincided with the arrival of a strange celestial visitor was in 1908, the year the Tunguska explosion devastated Siberia, leveling thousands of square kilometers of forest without leaving a crater. What if Tunguska wasn't a random cosmic accident, but an earlier phase, reconnaissance for what is now unfolding? That historical echo rattled even the most cautious researchers. Why would an object presumed to be a wandering interstellar fragment arrive on dates that once drove ancient civilizations to carve warnings into stone and align temples with the sky? Unless it wasn't wandering at all, unless it was pacing itself, guided by something that recognized these cosmic windows. By the time international teams compared notes, coincidence no longer felt like a valid explanation. The evidence pointed toward deliberate timing. But as the world focused on what was approaching Mars, few noticed that the visitor's influence might already have reached us, not through impact, but through our own minds. The mind lock. Is the visitor reaching out to us? It turned out the comet wasn't just disturbing a planet. It was already touching us. Soon after the 17-minute pulses were confirmed in Mars's seismic tremors, researchers at Princeton decided to test whether the same rhythm could reach the human nervous system. They converted Webb's optical light curve data into a low, steady audio tone and played it through headphones to volunteers placed in soundproof, shielded rooms. The subjects were guided into slow-breathing, meditative states so that ordinary brain chatter would quiet down. What happened next unsettled even the most skeptical neuroscientists. Instead of showing random individual variation, the EEG traces from separate, isolated subjects began to align. Their neural oscillations drifted into the same rhythm, the comet's rhythm, as if the distant pulses were a metronome they could not hear but somehow felt. The team called it entrainment, the tendency of one oscillation to pull another into step. But no one had seen it occur with such range and precision. The effect was not a trick of suggestion or sound. It appeared to be a real physiological lock-in to the same signal that was shaking the Martian crust. That link, comet to Mars, comet to mind, forced researchers to widen their view. If this resonance has happened before, might it have left traces in humanity's oldest sky records? A group of archaeoastronomers began cross-checking the comet's inbound trajectory with ancient texts. On a cuneiform tablet in the British Museum, a line stood out: "The fire serpent that bends toward the Red Wanderer, bringing the Great Awakening." The Red Wanderer was the Babylonian name for Mars. When the text's positional descriptions were mapped against present orbital models, they lined up with disturbing accuracy, the same long looping approach past the Sun and the same final inward bend toward Mars. To many in the field, this was no longer dismissed as mythic visions. It reads like scattered memories of previous cycles, eras when something like 3I Atlas passed close enough to stir a planet and perhaps reach the species watching from afar. 3I Atlas may not just be on a collision course with Mars. It may be part of something older, something that has reached across time to stir a planet and, somehow, us. The tremors beneath Mars, the pulses in our brains, the ancient warnings carved in stone, they all feel less like coincidences and more like steps in a plan. Maybe the impact we fear won't come from the blast on Mars's surface, but from what wakes up beneath it, or what is already inside us. So, we'll leave you with this. Do you think 3I Atlas is just a wandering comet, or a message finally being delivered? Tell us in the comments section below. We want to hear your thoughts. And if you want to follow this story as it unfolds, subscribe, because the next chapter might not just change how we see Mars, it could change how we see ourselves. Thanks for watching. See you in the next one.